Hello, and welcome to another Roberts Robotics video. This is part 4 of our series building this robot rover. I've made a lot of progress in the construction since the last part, and I've added a whole nother level here to hold up a sensor, and I'm going to explain what I've added and some of the parts that I've used. Let's start with the fact that originally I had just done all the power wiring, some of the motor control wiring, and I had added this DC distribution board. Well, as you can see, I ran out of connections down there, so I ended up adding another DC distribution board over here. I also ended up needing a 3.3 volt power supply because the LiDAR sensor required 3.3 volts. So this DC distribution board I split into 5 and 3.3, and the LiDAR is connected to that one. So that was one major addition, and it had to add a lot of wires for that. Now that DC distribution board, this is one of my own products, and those are available on our website. Then I had to add wiring for all the sensors that I've added. Now we added 3 ultrasonic sensors, left and right, and then in the rear. The one in the rear is mounted on a little plastic mount that you can get. I think I bought these on eBay somewhere. They're pretty common. And then the ones in the front I've mounted on servos with kind of a little custom mount that I came up with, and I'll show you that later. The other thing that I've added is the LiDAR sensor, and this is just a single range detector. Basically just measures the distance that is pointed at, not one of the spinning ones. So this is a simpler one, lower cost. I think it was only about $25 or something like that compared to the $130 or $150 it costs for the spinning kind. So this is basically just a point and shoot kind, and I'm going to try to use it just to see the way ahead of the rover to see if it's clear. And it has a longer distance than these sonar or ultrasonic ones, so I think that's going to work out well for that task. And I've got it on a servo so that I can move it back and forth, so I can pan a certain area ahead of the rover and see if the area ahead of the rover is wide enough for the rover to go through. That's the plan anyway. And then these ultrasonic sensors, if I'm running parallel to a wall, let's say I'm going down the hallway of my house, these will measure the distance to the wall, and I'm going to try and write code that will actually detect that you're getting too close to the wall, and that will alter the path of the robot to keep it away from the wall. So that's the idea. Then if I'm going forward and I'm not worried about checking the walls, I can servo these toward the front, and I can use them to detect obstacles in the front that maybe the LiDAR detector might miss, or if I'm getting too close to something, this would be a secondary way of making sure I don't run into it. A lot of extra wiring here. The servos are on this servo controller. Again, a little eBay or Amazon item that you can buy. I think it does 16 servos. And that one communicates to my Mega via the I2C bus. And so I've got 2 things now that are on the I2C bus. So I've got the LiDAR and the servos, and so I added this DF Robotics expansion board for the I2C bus, and that gives me a bunch of different places to plug things in, so anytime I add another item that needs to be on that bus, I can just plug it in right there. So currently I have those 2 devices, and they all have their own address, and I can just, in my programming, decide which one I want to talk to. Currently I am only running servos and the gripper arm. I haven't written code for anything else. The last video you saw the motor's actually running a test program, and so this video we have again another test program that I'm running that is only going to exercise the servos and the gripper up front. And that's as far as I've gotten with the code so far. The other thing I want to mention is there is a level shifting board that I tied right in here. Interesting thing about this LiDAR detector is that it uses 3.3 volts on the I2C communication, but it requires 5 volts for the main power supply. So again, that's why I added my extra distribution board. I've got both 3.3 and 5 here, and so the LiDAR is connected into there. And then I have this level shifting board because my I2C from my Mega is all running on 5 volts. So the Mega is on 5 volts and the I2C bus is on 5 volts, as is the servo controller. So I had to put in this little, again, you can get these on eBay, these little level shifter boards, and it's tied into the 3.3 and the 5 volts right here on my distribution board. In fact, what I did is I just soldered in some bus wire, and then I put the bus wire straight into this connector, so it acts as a mount and as the power source for the little level shifting board, and that converts it from 5 volts to 3.3 for my communication to my LiDAR. The other thing that I added was this IR sensor up front for the gripper, and that's going to detect when something is in the gripper and cause the gripper to close. My overall plan initially for this is I'm trying to get this rover to be able to run around a room without hitting anything, hence all the ultrasonic sensors. If I'm backing up, there's something back here, this will stop it from hitting that. I've got these where I can turn them to the sides and to the front so I can avoid hitting things. And then the LiDAR sensor is going to hopefully be used for a little more longer range to find out which direction I can go where there's, a good path ahead of me. Now the gripper, I'm going to have it just for now detecting when something's in its area and it will close, but the idea is that those servos would lower down to a point where you could pick something up on the floor. The gripper would, you'd run the gripper into that, over that item, it would close. You could lift it then with the servos, and then you could carry it off somewhere. Now what I'm going to do is when I back up, I'm just going to have the gripper open at that point, so you could literally like just pick something up, travel around with it, set it back down, back up, and it'll let go of it. So that's the initial plan. So all of this is just going to be, hard coded into the Mega, Arduino Mega that I have here. It's all going to be fairly basic, straightforward code. Eventually, I might try and do something a little more intelligent with it. Eventually, I may add an AI camera or something like that, and then some of the little AI cameras that they sell now, you can actually have it try to follow an object. Don't know if I'll get that far with this one. We'll see. At this point, the goal right now is just to get this thing to be able to maneuver through a room without running into anything, and just an added little feature of trying to be able to pick something up with the gripper. Okay, so next I'm going to show you basically how it works, powered up, and again it's only running an exercise program, and things are just going to be going back and forth, and the gripper will be active, and then I'll be able to put my hand in there or some object and it should close down on that. Now I do want to mention that I'm on my test bench here, and there's a couple things I do want to point out. So I have my scope, I can look at signals and see what's going on. Initially when I wrote the code for this, of course a lot of things don't work, and you get the scope and you can check things to find out what's working, what's not working, and so that's what I've been doing here on the bench. I want to point out that I have my battery charger plugged into my charger port here, and that way while I'm working on the robot with the power on and checking signals and whatever I'm doing, I can just leave it on if I want, and the charger will keep the battery from going dead while I'm doing my testing. Another thing I want to point out is you see I've got a scope probe in here watching a signal, and I want to basically explain to you my little, I showed you these last time, but these are the little wire terminators that I built myself. And the idea is I took a screw terminal like this and a pin header like this, and I soldered them together, and then I was able, with that you can put your wires in here, and then it just plugs right in. And the other thing I did with these, most time your pin headers are going to be fairly short like this. Well, I bought some longer ones, so these pins are a little bit longer, and that way when I plug this thing in, I still have a space underneath it where I can actually attach my scope probe, and I can monitor signals. So I'll show you how that works. So I can actually put my scope on that pin, and I can plug this thing in, and now I've got my scope right on that signal. So if I want to monitor that signal, there it is. I can clip onto that. If you want to also, you can go from the top as well on the way this is, with the way this is soldered together. There actually are some exposed pins on the top, and you can just about get a scope probe on the outside of that as well. There, see, I can clip onto the outside. So that makes it really nice when you're trying to figure out what's working, what's not working. You want to check a signal. Really nice that those are available for the scope probes. Same thing over here. I used a right angle pin header and soldered these onto that pin header. I could pull this whole thing out if I just want to disconnect it from the board. It also gives me a really nice spot to just hook up a scope probe right there, and I can watch that signal. So that's a really handy feature, because sometimes when you're trying to figure out what's wrong with something, when I first wrote all the code for this, none of it worked, and I had to go in and debug everything. And the scope sometimes can be helpful when you're really not sure what's going on. You can put that on there and actually see if the signal's there or not. Okay, I want to show you some of the items that I've used up to this point. You saw this, which I have on the rear here. I want to talk to you about how I mounted that in there. These little boards have holes in the corners that are so small you can't really even get a screw through those things. So what I've done is I just used bus wire in this case and wrapped it through the holes onto this item. Now for my servos, it's a little different. I actually have the servo horn that came with the servo. Usually when you buy these servos, you get a whole little kit of these little arms that go on the servo, and I actually use one of those arms along with some plastic standoffs that I bought separately, and I think I got all that stuff on eBay, little standoffs. And then what I did was I actually soldered bus wire through those holes, and here's the standoffs and the servo arm, and just made it so that I can just put that right on there, and then I've got that thing on a servo mount. The other thing I want to point out too is I made all these cables. I talked about that the last time. These are just made with socket headers and soldering the wires on and cutting these to size. So it makes a really nice setup. Everything just plugs in and put it like that, and away you go. You have a ultrasonic sensor mounted on a servo. Some other things that I've used, here is a servo mount, really nice servo mounts. I bought these at Servo City, and that's what the servos are mounted to. I had to drill holes in the chassis for these, and they're down on the chassis, screwed right into the chassis, and then the servos on top of those. So they're really nice servo mounts. The other item, of course, I have you've seen these on eBay or whatever, these little infrared sensors, reflective sensors. I've got one of those on the gripper up front. And then this item here, this is what I used to mount my LiDAR. This was perfect. I mean, it's almost the exact size that the holes line up perfectly and everything. And again, I got this at Servo City, so it's just a little L bracket, but interesting shape, but it fits the LiDAR perfectly, so that's what's holding that one up. Okay, so now we're going to turn the power on, and the little exercise program that I wrote will start running, and we'll see some movement here. So it's just an exercise program, moving each servo I do have them adjusted about where I want them, pointing out to the sides, pointing forward. The LiDAR is just sort of panning ahead. Now eventually I will have the LiDAR stopping at each point along the way and taking a measurement. So we move, take a measurement, move, take a measurement. And these, as I described before, will either be pointing out to the sides or forward. So now if I put my hand inside the gripper here, it should close, and it does, and got my finger in there. And the way I've written the code right now is I've got an interrupt closing this thing, and then it will eventually open up as it goes through the loop. So that's how the gripper works right now. Again, just an exercise program. So I've actually got this sensor on an interrupt that as soon as it sees that, it will close the gripper. And then as it goes through the loop, eventually it will open it back up. So the last thing I want to mention is I want to show you what we started with. This is the Roberts Robotics chassis. This is what we started with, and this is what we have now. And so I wanted you to see that. This is a pretty dramatic difference from here to here. And you can do this. You get a chassis like this and you can do this. And I also sell the chassis with a lot of the holes pre-drilled if you don't have a drill press or you just want it to be easier. These chassis are available at robertsrobotics.com, and if you've watched the video this long, this is the commercial for the product. So I hope you'll check out my website, look at the products, and maybe you could build something like this as well. All these parts are available either from Servo City or eBay, Amazon. You just need something to start with. You've got to have a base to put it on. And so that's why I really want to emphasize that this is all we had to begin with. And this is what we have now, an actual robot rover that you can build. So I hope you've learned something and hopefully get inspired to do this type of project on your own.